In today's note, we're going to be looking at distance time graphs. So traveling can be represented graphically using a special type of graph called a distance time graph. And from these graphs, we can make observations about three things. Two of them are in the title, so distance, time, and speed is the third one. So we can make observations, or we can make comments about these three things from distance time graphs. First one, time. We've talked about time before with scatter plots, and time is usually the independent variable, so is therefore on the x-axis, right? So that's that horizontal axis. So if time is independent, that means distance would be the dependent variable, and therefore it is on the y-axis. Speed is the slope or steepness of the graph, and it provides information about what the speed is. So the steeper the line or the curve, the faster or higher the speed. The less steep the line or curve, the slower or lower the speed. If you have a horizontal or flat line, it means the object was stopped, and that means that our speed is 0. If we have a linear relationship, and we've talked about linear relationships before, a linear relationship means that the speed is constant. So it means it's the exact same across the entire line, while non-linear relationships means that the speed is either, we can say, accelerating or decelerating. Or in other words, that the speed is not constant. Right? Accelerating means it's always increasing, decelerating means it's decreasing over the time. So in our first example, for the given distance time graph here, we want to describe the motion. So we have three different sections. We'll label them 1, 2, 3. And if I want to describe the motion in the first part, we would say that you are moving towards whatever our reference point is. Remember, we talked about the line going down means we're moving towards something. So we're moving towards constant at a constant speed because it is a straight line. Constant speed, you could say it's moderate to fast speed. You could say that it is 3 seconds long, that second or section. And you could say that you traveled 4 meters. In number 2, in this section, we are stopped because it is a flat line. Speed is equal to 0. And you could say that it lasts 3 seconds. In number 3, here we could say that it is, again, moving towards. You could say that it is accelerating. Or you could say not constant speed. You could also say we traveled for 2 seconds and a distance of 4 meters. So all of that would work. So that's how you would describe each of those sections. All right, in example 2, we want to draw now a distance time graph focusing on the distance from home for the following situation. And in this situation, Mr. Liu is taking Chester for a walk. They leave home walking at a steady pace. After 4 minutes, they begin to slow down and then stop for 1 minute to get a coffee at Tim Hortons, which is 500 meters from their house. They turn around and run home at a constant speed, which takes 2 minutes. So looking at our distance time graph, the first thing I want to do is add some numbers or add a scale. This, so on the bottom, our time, we're going to have 2, 6, 8, 10. So each box is a minute, and going up, each box will represent 100 meters. All right, so there's a couple different sections to this scenario. We'll go back and highlight them. First thing is they leave home. So that means we're starting at our reference point down in the corner. They're walking at a steady pace, so that means it must be at least a straight line. And after 4 minutes, they slow down. And then they stop for a minute to get a coffee. At Tim Hortons, it's 500 meters away. And they turn around and run home at a constant speed for 2 minutes. So that means after 4 minutes, we're slowing down. So let's say we are walking at a pace to 300. And now we're going to slow down until we get to Tim Hortons. So since there's no actual time on how long we're slowing down for, but we do want to make sure that our line is not as steep as this first line. So let's say it takes us 3 or 4 minutes. So because it is slowing down, as long as we have, actually let's make it 9 minutes. So as long as this line is less steep, it means we're slowing down. So that takes us to 9 minutes. We stopped for a minute to get coffee, and we're at 500 meters from our house. And then we turn around and run home in 2 minutes. And it's going to be at a constant speed, which is our straight line. So that would be what our distance time graph would look like for this scenario. There are some parts that you can kind of make up as you go, but as long as you have something roughly in this shape, it should be good. So how long did the entire journey take? Well, looking at where we started at 0, 0, and where do we end, that means a total time of 12 minutes. Again, your graph, it may be different, but as long as you're looking at where the final point is coming back home, that would be your time. And looking at it, what happened to the graph when you turned around and traveled home? Well, the graph or the line went down. So again, the key thing to remember here is that going down does not mean falling down or going down levels. It means returning home or walking towards whatever our reference point. So again, the key thing from this note is just to, again, understand how distance and time can be represented on a graph and what those characteristics of a distance time graph are.